Okay, let's dive into this. Welcome to today's Explainer, where we are going to uncover some of the most thrilling origin stories in history. Now, when you hear the word math, you might just picture a dusty chalkboard full of complicated numbers. But today, we are going to change that completely. We're looking at an extraordinary group of brilliant minds, all born in the month of April, who didn't just solve equations, they unlocked actual superpowers that literally built the modern world around us. Because, as you'll see, imagination and math totally go hand in hand.
Here is our superhero lineup for today. We've got the Rebel of the Revolution, the Master of Connections, the Shapeshifter, the Digital Architect, and finally, the Prince of Patterns. Let's go meet our very first hero.
Section 1. The Rebel of the Revolution. This is Sophie Germain, born April 1st, 1776 in Paris, France.
To really understand her superpower, you have to understand her world. The French Revolution was literally raging outside her window, and society absolutely did not believe young women should be studying mathematics. In fact, her parents were so desperate to stop her from doing math that they took away her warm clothes, her fire, and her light. But Sophie, she was a rebel. She waited until her parents were fast asleep. Then, pulling out a hidden little stub of a candle, she wrapped herself up in every single blanket she could find. Just picture her there, right? In the freezing dark, her breath misting in the icy air, secretly solving these complex equations by the flicker of a single tiny flame. It's like this thrilling mystery unfolding right in the shadows of Paris.
Well, all those freezing nights led to a massive breakthrough. Sophie became obsessed with a mystery. She noticed how these intricate, beautiful patterns would magically form in sand when it sat on vibrating metal plates. They're known as Chladni figures. Watching those shifting sands, that was her big aha moment. From those vibrations, she developed the incredibly complex math of elasticity. This is the math that explains exactly how surfaces bend, how they vibrate, and most importantly, how they resist breaking under immense pressure.
And this brilliantly illustrates how Sophie Germain gave humanity the superpower of structural superstrength. Engineers actually used her groundbreaking work on elasticity to help design the Eiffel Tower, making sure that massive iron structure could safely withstand the intense vibrations of the wind. Today, every single time you look up at a swaying skyscraper that doesn't fall over, or drive across a sturdy, massive bridge, you are seeing Sophie's secret math in action.
Moving on to Section 2. The Master of Connections. Leonhard Euler, born April 15, 1707 in Basel, Switzerland.
Euler's story is it's awe-inspiring. He actually lost his eyesight completely. But did that stop him? Not for a second. Picture this incredibly relatable but remarkable scene. A blind man sits at a simple wooden table with his kids just playfully running around his feet. Despite living in total physical darkness, his mind is completely illuminated. He's dictating brilliant mathematical formulas to his assistants at lightning speed. Because he couldn't see physical objects anymore, he learned to see the world differently, purely as this beautiful, invisible web of connected dots and lines.
This totally unique way of seeing the world led to an epic mystery-solving moment with the famous 7 Bridges of Königsberg puzzle. People had always wondered if you could walk across all 7 bridges in the city without crossing the same one twice. Well, Euler didn't even bother measuring the actual bridges. Instead, he stripped away the physical world completely. He drew a simple diagram using just dots for the land and lines for the bridges. By doing this, he invented an entirely new kind of math, graph theory. He proved that when it comes to networks, the specific arrangement of a path matters vastly more than the physical distance.
Euler's dots and lines are what we now call nodes and edges, and let me tell you, they are the ultimate modern superpower. It's exactly what powers the networks you use every single day. When your family uses Google Maps to find the absolute fastest route to a friend's house, or when social media magically suggests new friends you might know. That is Euler's math at work. The computer is literally just looking at the dots and lines of your digital life to connect you to the world.
All right, up next is Section 3, the Shapeshifter. Henri Poincaré, born April 29, 1854 in Nancy, France. So Poincaré wasn't your typical rigid scientist. He was more of a daydreaming professor whose mind was constantly lost in the clouds of his own imagination. And honestly, it was precisely that daydreaming that led to an amazing breakthrough. Imagine him casually stepping onto a local bus. The exact millisecond his foot touches the bus step, an absolute mathematical explosion goes off in his brain. A completely formed brilliant idea just hits him out of nowhere. He suddenly realized that the universe isn't just made of rigid, straight lines and perfect boxes. No, the universe is actually this wild, flexible world of stretching, bending, and folding.
That sudden bus step revelation, it birthed a totally new field of math called topology.
Think of it as rubber sheet geometry. In topology, a shape's core identity remains exactly the same, even if you stretch it, twist it, or fold it, as long as you don't tear a hole in it. It's the ultimate shape-shifting superpower, focusing entirely on the fundamental properties that survive no matter how much you pull or squeeze an object. Now, what's really interesting about this is a classic topological riddle: a coffee mug versus a donut. To you and me, obviously, they look totally different. I mean, you drink out of one and you eat the other. But to a topologist like Poincaré, a coffee mug and a donut are mathematically perfectly identical. Why? Because they both have exactly one hole. If they were made of clay, you could smush and stretch the mug until it looked exactly like the donut, without ever having to tear a new hole. Pretty mind-blowing, right?
And hey, this isn't just some fun party trick with breakfast foods. This abstract shape-shifting math is absolutely critical to modern science. Today, astrophysicists use topology to try and understand the actual physical shape of the entire universe. And even closer to home, doctors and biologists use Poincaré's math to understand how DNA molecules, the literal building blocks of life, coil, knot, and fold themselves up tight inside your very own cells.
Let's jump to Section 4, the digital architect. Claude Shannon, born April 30th, 1916 in Petoskey, Michigan. Shannon was a brilliant American scientist, but man, was he delightfully unconventional. He was famous for literally unicycling down the long, echoey hallways of his research lab, just casually juggling 3 balls while he rode. He was eccentric, super energetic, and he saw the world completely differently than anyone else. While we walk around seeing pictures and hearing sounds, Shannon looked at the world and saw a constant, flowing stream of pure information and electrical pulses.
While juggling and unicycling, he stopped to ask one earth-shattering question. Think about this for a second. What is the absolute smallest unit of information? If you strip away the music, the colors, the words, what is left at the very, very bottom? The answer he discovered was remarkably simple: 0 and 1. Shannon invented information theory. He proved that absolutely every human thought, every beautiful song, and every vibrant image can be perfectly shrunk down into a tiny string of zeros and ones. He called these bits. He proved that as long as you have a basic yes or a no, literally just an on or an off switch, you can perfectly communicate absolutely anything across the entire universe. I really want you to realize something incredible here. You are only able to watch this explainer right now because of Claude Shannon. Every single smartphone in your pocket, every invisible Wi-Fi signal bouncing around your room, and every single movie you stream on Netflix relies entirely on Shannon's math. His information theory is the digital architecture that perfectly translates light and sound into binary code, zeros and ones, and then blasts it across the globe.
And finally, Section 5, the Prince of Patterns. Carl Friedrich Gauss, born April 30th, 1777, in Braunschweig, Germany. Long before he became a famous mathematician, Gauss was a child prodigy whose mind just worked faster than anyone could even comprehend. Imagine a dusty wooden desk classroom in Germany. A tired teacher, desperate for just a few minutes of peace and quiet, gives his students a massive punishment assignment. Add together every single number from 1 to 100. 1 plus 2 plus 3 all the way to 100. While all the other kids groan and start sweating over their heavy chalk slates, 10-year-old Gauss looks at the numbers for exactly 5 seconds. He spots a hidden pattern, writes down a single number, and walks it right up to the teacher's desk. He had the answer instantly, just because he saw how the numbers paired up perfectly.
That childhood superpower of spotting hidden patterns? Well, it became his lifelong work. Gauss went on to popularize the normal distribution, which you probably know as the bell curve. He looked at the chaos of nature and realized it wasn't chaotic at all. From the exact height of trees in a huge forest to the tiny weights of individual blueberries on a bush, he found that natural things almost always cluster symmetrically right around a middle average, creating this perfect, beautiful hill-shaped pattern. So the crucial point is that Gauss gave us the superpower of prediction. His famous bell curve is the absolute foundation of modern statistics. Today, we use his math to look at tiny pieces of data and predict massive global events. It's how meteorologists forecast next week's weather, and it's even how companies predict exactly how many people are going to buy a brand new video game on launch day. He basically showed us that the whole world has a rhythm.
From shivering in a dark Parisian room to unicycling down a laboratory hallway, these April-born pioneers prove that math isn't just about memorizing boring rules. It's about looking at the world, asking wild questions, and having the imagination to see the invisible connections all around us. The world is still full of hidden math mysteries hiding right in plain sight, just waiting to be solved. So, as we wrap up this explainer, I'll leave you with this question. What hidden pattern will you discover next? Keep exploring, keep questioning, and I'll catch you next time.